When you are trying to do immunization of a bond portfolio, you are managing a portfolio of assets to meet a future liability. You need to do some calculations. Let's see some of the calculations involved with cushion spread and initial safety margin. Let's say we're starting with the present value of our portfolio. This is the present value of our portfolio. And we're trying to manage this portfolio to meet a certain liability. And let's say our required minimum return is a certain percentage here. We can use this rate to compound our present value using our minimum required return to get our future value. That would be our required terminal value. Of course, this would be our investment horizon. And then we would look at the market and we ask ourselves, what's the immunization rate, or what kind of market interest rate is there that we can buy certain kind of instruments carrying the market interest rate. And if we buy those instruments, we will still be able to meet the required terminal value. So usually the minimum rate is lower than the market rate. So we can apply a higher market rate to the required terminal value and then get a new required minimum assets that we must have in order to use the market interest rate as our immunization rate to meet our required terminal value. And then the difference between the present value of your portfolio and the minimum value you must have to use the market rate, this will be called the initial safety margin. And then the interest rate differential between the minimum interest rate and the market immunization rate, the interest rate differential is called the Cushing spread. Let's do an example and put some numbers to those concepts so that every formula makes sense to you. Let's assume that currently we have a portfolio and the current value of our portfolio is $10 million. We're managing that portfolio. And let's say we need to have a minimum return. Our investment committee decided that to meet the future liability, we need at least 7%. And let's say our investment horizon is 4 years. Of course, we are extracting these numbers from the problem. Let's say sometimes the problem will give you some extra data to distract you. Let's say the investment policy committee decided the time horizon is 4 years, but they can tell you that the current assets is invested in a 20-year bond. Remember, the 20-year bond, that 20-year is a distraction, so you ignore that. Then the problem might tell you that the economists working for that pension fund thinks that the market interest rate should be 9.5%. Okay, don't be distracted by that number. We know the immunization rate should be the current market rate. Then later on in the problem, they would say, okay, the current bond market gave you opportunities to immunize your portfolio at a rate of 8%. Now we need to do some calculation. We know the Cushing spread, that's easy. Market rate, that's available for you to use to immunize the growth of your assets, is 8%. So here we use 8% minus the minimum rate that we require from this portfolio is 7%. We would get 1% as our Cushing spread. Then we need to calculate the required terminal value. And that's pretty easy. What we can do is we know the present value is $10 million. We multiply that by the minimum required return that we must have. Remember here, the semi-annual convention kicks in. So we have to use semi-annual compounding over here. We have 7% divided by 2. That's our half-a-year rate. Then we have 4 years in the time horizon. So 2 multiplied by 4, we compound that by 8 years. We will be able to get our future value. That's 13.16809 million. That would be our future value, the required terminal value. Then we say, from that required terminal value, if we immunize our portfolio today, and to immunize, it's easy. To meet that future required terminal value, you just buy a zero coupon bond, giving you 8%, and then that zero coupon bond will mature 4 years from today at a value of 13.168 million, right? We can calculate the present price of that zero coupon bond, because zero coupon bond is the perfect instrument to 100% immunize a single liability. Okay, the only thing we do need to do is to apply this 8% discount rate. And the calculation is going to be easy, and you can use your calculator. What you can do is you put 13.168 million as the future value. You input that into your calculator. The big N, the number of periods, is 4 multiplied by 2. N is 8. That's our investment horizon. You input that. The interest rate this time is going to be 8%. Using semi-annual convention, 8% divided by 2, you input an interest rate of 4. Of course, we're buying a zero coupon bond to meet that future liability, so the payment, periodic payment, is 0. And then you hit compute. You'll be able to get a present value over here. That's our minimum that we require. That would be a 9.6218 million. So our initial safety margin is going to be the difference between $10 million and 9.6218 million. Essentially, our initial safety margin will be 0.378 million, approximately. We also need to understand a very important concept called contingent immunization. The idea of contingent immunization is, let's say you have an initial safety margin. The minimum assets you need to use the market immunization rate to buy zero coupon to meet a future liability, let's say it's 9.6 million, and currently you have 10 million. You have more money. So you can pursue an active strategy. You can make some bets. You can fool around a little bit. But if your portfolio drops below the minimum that you need, the alarm would ring. And then you will have to invoke the immunization, the contingent immunization plan. Essentially, you will be forced to buy zero coupon, because otherwise, if your portfolio drops further, you won't have enough money to meet the future liability, and you will be in trouble.